Welcome back, and as promised, I'm going to share some of my multiple choice questions with you. I'm not going to post up CXC's multiple choice questions because we're not supposed to have them. Okay? Those can be requested privately. Okay, so let's start with weights and springs, and this is usually the first topic, well, in most courses, first, second, or third topic, because usually for me, I start with the universe, and then I move on into math, physics, maths and physics, and then I would then move on to this, weights and springs. And usually universe is a popular topic. It's really fun. So, yeah. Which of the following units, this is weights and springs, so which of the following units below is not a basic quantity? So we have options A, Pascal, B, kilogram, C, candela, and D, we have K for kilo. Right? So which one do you think it is? Well, we could cross off B, because B is a basic quantity. It says which one is not a basic quantity. Oh, sorry, D is actually Kelvin. Alright, so B is a basic quantity, sorry. This one represents temperature, which is a basic quantity. Candela is also a basic quantity, so we'll say Pascal. So guess what? The basic quantities are, you have mass, you have length, you have temperature, you have time, you have current, you have amount of substance, and then you have luminosity. So these are the units for those 7 basic quantities. So mass, the unit is kilogram. Distance or length, the unit is meters. Temperature, the unit is kelvins. Time, unit seconds. Current, units amperes. Amount of substance, units moles. And for luminosity, you have candela. So candela is a basic quantity. 7 basic quantities. These 2 we don't usually pay attention to. There are dash basic quantities, so that was the next question. Like I said, we have 7. Then the SI unit of density. Now we have to pay attention to the word SI, right? So the SI unit of density is not this one. It's not this one as well. Let me make this bigger so you can see it. It's bigger. Okay, so yeah, this is much better. So the SI unit for density is actually kilograms per meter, and written the other way is kilograms kilograms per meter square. So written that way, you have kgm to the -3. So this one goes, A is not, B is not it. So we have grams gone. And then this one is not, the 3 is not negative. This one, C, the 3 is negative. Okay, so all of the following are dimensionless quantities except, so which one is not a dimensionless quantity? Magnification is a dimensionless quantity, so is relative density, and so is refractive index. So your answer would be luminosity. It has units of candela. Dimensionless means that they don't have any units. So magnification, it wouldn't have a unit. Relative density doesn't have a unit, nor does refractive index. Okay, so the following equation, EK equals to mv squared, is used to calculate kinetic energy. if m instead of ek were the subject of the formula, it would be equal to, so if you want to make this easier for you, we say ek is equal to mv squared over 2, because you have to multiply throughout. And to solve for m, you have to multiply both sides by 2, and the 2 over here will cancel, and then you have to divide both sides by v squared. Now I'm doing this thinking that you would have already listened to all of my read-alongs, so I'm assuming that you would have some knowledge of what we're doing right now, but I'm still going to help. And so the answer is m is equal to 2ek divided by v squared, and that gives us b. So far we have A, D, C, B, B. And I hope you got those answers as well. Now the speed of light in a vacuum is 3 times 10 to the 8 meters per second. How many significant figures are there in the value above? How many are there? There's just one. You don't pay attention to this over here, it's just one. So the answer here is A, 1. 7. Let's scroll down a little bit. It says the unit of the value representing what, here we have basically a graph. A graph, we have extension in meters against load in newtons. And the unit of the value represent y2 would be in meters. Because y2, it would be the coordinate taken from the y-axis, which is the extension in meters. Okay, so I'll make it bigger if you can't see it. I'll make it bigger for you. Right, so you can see the extension right there. Okay, then it says an appropriate title for the graph would be, now if you have extension, any graph that has extension in meters against load in physics would automatically be explaining the spring constant of a spring. So you already know it wouldn't be the acceleration of a pendulum, it wouldn't be the value of gravity, and it wouldn't be density. And you always have to look at the units here. So basically the units of this, if you have delta y over delta x, the units would definitely be m over newtons. And the spin constant is actually newtons per meter, because that's the force. So you will be finding the inverse of the slope. So this is how you solve for the slope. So the answer here will be determining the spring constant of the spring. And what I was getting at with that is that it's usually whatever you're looking for on the slope is actually where you would put for your title. So if it was a gravity graph, it would have probably been something involving newtons per kilograms or meters per second squared. But then again, the meters per second squared could be attributed to acceleration. So whatever units you get is what would tell you what your graph is about. Like density of a liquid, you usually have units of kilograms per meters cubed or grams per centimeters cubed. So something like that would have told you. So you always have to look at the units that your slope would be given off, the units of your slope. And once your slope give you a certain type of units, you start to think really hard. So if you have a slope that is distance against time, guess what? You'll be looking at something like speed, right? The speed of some kind of object. Okay? Now, which of the following equations can be used to determine the slope of the graph? Now, you don't determine this. The slope is determined by dividing. It's the ratio of the difference in y values or coordinates by the values, the difference in x coordinates. So it has to have y on top. So A is already gone, and then we have B, C, and D. Now it's supposed to only be y coordinates on top. So you see y and x up here on top, that already goes. Now you have only y and only y for C and D. But whatever you start off with at the top must start off at the bottom. For instance, C is telling you y2 minus y1 over x1 minus x2. If you start with a 2 up here, you must start with a 2 down here. So this one goes. So this one is y1 minus y2 over x1 minus x. So if it was y, is this, so this is x y1 minus y2, sorry, over x1 minus x2. You could also have y2 minus y1, but below must have x2 minus x1. It must go in order. Okay, so D is our answer here. The slope of the graph would have units of Newton per meters per Newton, correct. So this is also meters, and then you have Newton minus 1. So meters per Newton, and that will give us D. So that's the answer for 10. 10 is D. Now the dependent variable is, let's look at the graph. Which axis depends on the other? So the x-axis is always a dependent axis. And sorry, the x-axis is the independent axis. I'm sorry, it's independent, right? And the y-axis is the dependent axis. This is the one that you're looking at, you're judging, and it's dependent on whatever is being added to it. So the extension is dependent on the load that's being added. So your dependent variable would be extension. It wouldn't be load. There's only two really possible choices that were here, because we only had two axes. That the extension, which was the y, and the load, which was the x. The gradient is the slope. So those two are not even. They're not. You shouldn't have even suggested those two. Okay, so looking at the drawing for question. Looking at the drawing for question 12, 11, 12, or 12, yeah. So I'm going to decrease the size a little bit. So it says the item below refers to questions 12, 13, and 14. We have a drawing, and it looks like a pendulum, and you can see here you have the amplitude, you have the point of equilibrium, the mass, one full oscillation. So you have one full oscillation, and you have the retard stand. The setup above may be used to measure watts. It's used to measure watts. Time, because pendulums are sort of timing devices, right? So it's not used for height or refractive index. Height, you need a meter rule or a ruler, something like that. Refractive index is about the bending of light in glass or whatever transparent object you have or substance. And then no to current. There's no ammeter there. Which variable affects the period of a pendulum? So period means time. So which one of these affect how fast the pendulum will move from one end to the next? Is it the length? Is it the mass of the bob? Is it the amplitude, meaning the angle from the starting point, from the resting point to where it's going to be released from? Or is it the weight? No, mass and weight are interrelated, so B and D are out of here. So it's either amplitude or length, and it is length. Okay, so moving on. It says, which of the following instruments may be suitable for measuring the length of a playing field? Which one? Vernier calipers, microscope, or gauge, a spectrometer, or measuring tape? So think about it before I give you your answer. Of course. Now vernier calipers, this is a vernier caliper down here. It's too small, too short. Microscope or gauge is even smaller. A spectrometer, no. So we have the measuring tape. So that's the most likely one, the best answer. Then it says, in the picture, the length of the object is, now when it comes to vernier calipers, this is the vernier scale right here, and it tells you this. And the answer is right here, so if you were looking for an answer for 14, you would know that this was the incorrect answer. This is the vernier scale right here to determine smaller length, so you won't have to guess. If you look here, you realize that this is 1, 2, 3, 4, 5. So it's 1 each time. So the rod, the diameter of the rod is past 5 and it's 6 point something. So you could say it's 6.7, 6.8, 6.5, but it's between 6 and 7. The vernier caliper, what it does is tells you it tells you the point something that you're looking for. All you gotta do is look at the lines up here and see which line lines up perfectly with a line down here on the millimeter scale. So this doesn't, this doesn't, this doesn't, this doesn't, this doesn't, this slightly, this does. So I would say I would stop right here. And so it looks like 6 point, let's count from 1, 2, 3, 4, 5, 6, 7, 6.7 millimeters. Awesome sauce. Okay. So let's make this a little smaller. How are we looking out there? I hope everybody is getting their answers correct. The volume of an irregularly shaped object may be determined by finding its mass. No, because then you'll be looking for mass. May be determined by dimensions of water. No, that's for something that's regular, and that doesn't happen with water. So blah blah. Displacement of water. This makes sense. Determine its density. No. So displacement of water means that you have a known volume of water in a measuring cylinder, something that's graduated like this down here, and then you put the irregular shaped object inside of the water once it can fit in the hole, and you measure the final volume, subtract the initial volume from the final volume, and voila, you have the volume. Okay, so the instrument above is used to measure volume. It is referred to as a graduated cylinder. Definitely, you need to know your instruments, your lab instruments. It's not a beaker, it's not a top pan balance, it's not a volumetric pipette, it's a graduated cylinder. The density of copper is 9 grams per centimeter cube. Find the mass of 5 centimeter cube of copper. So we have the density. Now to calculate density, we have density is equal to mass divided by volume, right? We have the density and we have the volume. How do I know that this is density? Because of the units, grams per centimeter cube, which is also represented as G over cm3, right? And then the 5, I knew it was volume because it's centimeter cube. So we have the volume here. So we have P and we have V. It says you want the mass. So to solve from M, you just transpose. So this is why mass is very important in physics. You transpose. So now you know that mass will be equal to volume times density. The volume is 5 centimeters cubed. The density is 9 grams per centimeter cubed. These are going to cancel out to give you 45 grams. Do we have a 45 grams? Yay, that's A. So 18 is A. Good. Hope this helps. Hope this is helping. Keep me on your P's and Q's. Keeping my promises as well. All of the following are scalar quantities except, so a scalar quantity has only size but no direction. So it has size and no direction. Okay? So all of the following are scalar quantities except. So all of these are scalar. All these have only size except this has only size, this is only size as well, this is only size, but velocity has direction. Okay? Unit of velocity is meters per second. From this you don't see you have some direction here, and you have some size, some sort of size, because there'll be a number value in front of this each time. Now the SI unit, now the unit that is standard that we accept for force is newtons. It's not F. F was put there to throw you off. But and W is watts. That is the SI unit for power. And joules is the SI unit for energy. All of the following are contact forces except. So what are the forces that need to be in actual contact with something else except. So friction, you need to be in touch with something. So that's not it, sorry. Tension, you need to touch. You need to touch it to experience it. With nuclear, no, it's not contact. Nuclear forces, you don't have to touch it to know it's there. So that's non-contact. The other set of non-contact force is gravity. And another one, magnetism. Tell me about any more contact forces that you know of. Now the last question, I was trying to get 25 questions, but honestly the chapter is not too long and it's not heavy laden with information. It's just something to introduce you as a student. And so 22 questions is what I could have messed up. After that I would have been just making up non even these repeated questions going on and on, right? So if Lydia has a mass of 56 kilograms, what would be her mass on the moon? Gravity on the moon is 1.6 newtons per kilograms. Well, let's just think about it. Mass does not change anywhere you go. So her mass will definitely be the same. It'll be 56 kilograms. However, weight does. And if they asked about her weight on the moon, then you would have multiplied 56 by 1.6. Alright guys, this is the end of module 1 or section 1 of the CXC physics syllabus, and I hope I was able to help. If you'd like this test, just let me know. I can send it to you via email along with some other presents. Okay, if you have asked before and you didn't get anything from me, please know that I'm very busy right now trying to produce these videos for you, but still send out your requests. And if you don't get it, heck me, send me a message and tell me, hey, you didn't send my stuff. Okay, alright, hope this helps, and I'm gonna write the answers, all of the answers down for you right now in this space, so you could always look back. So answer 1 was A, 2 D, 3 C, 4 B, 5 B, 6 A, 7 A, 8 B, B, 9 D, 10 D, 11 A, 12 C, 13 A, 14 D, 15 B, 16 C, 17 B, 18 A, 19 C, 20 B, 21 A, and 22 is B. Okay, and of course, over time I'll get more creative in how I make my questions, so do look out for more multiple choice coming soon, maybe this summer. Alright, bye now, enjoy.